The double-slit experiment is one of the most famous and intriguing experiments in the field of physics, particularly in quantum mechanics. It's designed to demonstrate the wave-particle duality of particles, showing that they can exhibit both wave-like and particle-like properties under certain conditions. This experiment has profound implications for our understanding of the fundamental nature of particles and the behavior of quantum systems. Here's an explanation of the double-slit experiment. Experimental setup. 1. Imagine a barrier with two narrow slits cut into it, side by side. 2. On the other side of the barrier, there's a screen or detector that can record the arrival of particles or photons, particles of light. Experiment with particles, e.g., electrons. 1. Initially, let's consider shooting individual particles, e.g., electrons, at the barrier with the double slits. 2. When these particles are fired one by one at the barrier, you might intuitively expect them to pass through one of the two slits and strike the screen behind, creating two distinct patterns corresponding to each slit. Surprising results. However, the double-slit experiment reveals something astonishing. When individual electrons are shot at the barrier and observed over time, they create an interference pattern on the screen, similar to what you'd see if you were shining light through two slits. This pattern consists of alternating dark and light bands, indicative of wave-like behavior. Wave-particle duality. This result challenges our classical intuition. It suggests that the electrons are behaving as waves rather than particles when they pass through the two slits. They interfere with each other, creating the pattern, as if they are waves on the surface of water creating ripples. Observation and collapse of the wave function. To further complicate matters, when researchers try to observe which slit a single electron goes through, by placing detectors near the slits, the interference pattern disappears. Instead, each electron behaves as a particle, and you see two distinct patterns corresponding to each slit. This implies that the active observation collapses the electron's wave-like behavior into a particle-like behavior. Quantum superposition. The strange part is that until observed, the electron seems to exist in a state of superposition, meaning it is in multiple possible states, both slits, simultaneously. This superposition collapses into a definite state, particle-like or wave-like, only upon measurement. This experiment showcases the fundamental principle of wave-particle duality in quantum mechanics. Particles like electrons, photons, and even larger molecules can exhibit both wave-like and particle-like properties, depending on the experimental conditions and whether or not they are observed. The double-slit experiment raises profound questions about the nature of reality and the role of observation in quantum systems. It remains a cornerstone of quantum physics, continually challenging our understanding of the smallest building blocks of the universe.